All right, welcome to video number 9. This video, we're going to cover the four-stroke theory, what goes on inside of here in our combustion chamber. To begin, you have 4 strokes. That's why these are called four-stroke engines. And what a stroke is every time this goes either up or down. So within a cycle, this goes up and down 4 times inside there. But you can't see it very well on here, but I have a model that I made a while ago that you see it as it rotates up and down. So it goes up, down, up, down. And that's 4 strokes or 1 cycle of the engine. So what are the 4 strokes called? You have your intake, your compression, your power, and your exhaust. One way to remember that is some people call it intake, which is your suck stroke, compression, your squeeze stroke, your power, your bang stroke, and then your exhaust, your blow stroke. So suck, squeeze, bang, blow is a good way to remember how these things work. So let's take a look at this specific engine. So this side is our intake side and this side is our exhaust side. I know that because as I look around it, I've got my exhaust port right here where this would be, and I've got my intake, my carburetor, over on this side. So as I rotate it, they get it up to the top. As it's sucking down, it's going down, my intake is being pushed down and it's open. So let's see if I can get it in and get a good view inside there. See how that valve is open? I'll try to zoom. It's kind of hard to see, but as I rotate, let's see if I can get it to close. It closes, you see that right there? As it opens as I pull it down. So as the intake stroke, it's pulling the piston down, which is creating suction. And that's why it's called the suck. Intake, suck. So it sucks down. It gets down to the bottom. Now let's look at our valves again. Both of our valves are closed, right? Look in there, it's closed. They're not sticking down at all. So now it's gonna keep on going and it starts to come back up on our compression stroke, where now we have all that air fuel mixture in this chamber and it's squeezing it. And what that does is right before it sparks, it ignites in there. All this stuff is compressed tightly so that when it sparks and ignites, it like has more power to push down. So we'll keep on pushing up. Now right there is top dead center. Right before top dead center, we're gonna go ahead and have our spark go off. Our spark plug is gonna ignite whatever's in there. So everything gets compressed down to that size right there. And it happens right before top dead center. That way it gives time for the air fuel mixture to like burn and start the power stroke, which pushes down really fast and hard. It pushes everything down. And then at the bottom of the power stroke, the exhaust starts to open because the momentum we have built up from the power stroke is gonna push out all of that burnt gases through the exhaust valve. So let's kind of see if we can see it in there. See how that's open now? The exhaust valve's open and it lets all those burnt gases out. Keep on rotating. And there's a split second where they're both barely open, right at the top dead center of the end of our exhaust stroke, as it converts to the intake stroke, and it redoes the whole process as it sucks in air-fuel mixture, goes into compression and compresses that air-fuel mixture right before top dead center. Then it sparks, and then the power stroke happens and pushes this down, and the momentum from the power stroke and the counterweights on our crankshaft keeps this piston moving upward, has it start to go upward to exhaust all those fumes, get everything that we just burnt out of there, and then it starts it all over again. So that is kind of the process that happens. Drop you guys. So that's the process that happens as we rotate through these 4 strokes of a 4-stroke engine. So that is on this one right here. Now, all 4 strokes are gonna have the same strokes, and they're all gonna be pretty similar. So over here, on the one we're taking apart, as we rotate, our crankshaft, remember when we got our push rods even with each other? That was when it was at top dead center, remember? So right there, the intake is being pushed down. So we're on the intake stroke as we keep on going, and it sucks it through, sucks everything through our carburetor, sucks our air fuel mixture in. As it keeps on going, it goes through the 4 strokes as it starts to compress and so forth. Here we have like a drawing on the board that might help some of you guys understand a little better. On our intake stroke, so right here, we have our intake valve open that allows gas to come into the chamber as the piston's sucking down. Because there's suction, because you have no air able to get out between there because you got our piston rings and everything. So this pulls down, sucking air fuel mixture in, and we come over here and this starts to go up and it compresses our air fuel mixture. Notice both of our valves are closed. Then over here we have ignition and power, where boom, this is coming up, it goes boom, and it goes over here where it's all that power is being pushed down. Both of our valves are closed. All that power is pushing the piston down, and then it comes over to our exhaust where all the momentum from the flywheel and our crankshaft comes back up, exhausting it out, the exhaust port, the exhaust valve. And then that just goes in a circle. This goes through this cycle over and over and over. So while we have these pistons going up and down, up and down, up and down, the piston's connected to our crankshaft, remember? Well, as it's going up and down, it's got to be rotating that crankshaft, because our crankshaft has that journal that our piston connects to right here, right? So it's pushing down on it and it's rotating. Look, it rotates. It rotates it around, allowing for our engine to spin. And then you connect that to a lawnmower blade or a water pump, and that's how we get things to work with a small engine. Now, as you kind of see, like, you have your crankshaft gear connect to your cam gear, and then because your crankshaft's turning, your cam gear turns, which your cam gears connect to your push rods, which push your push rod cups, which push down your valve springs, which open your valve when you need to open them. So everything is timed perfectly. That's why we have our timing marks on our cam gear and our crankshaft gear. So this is the end of video number 9, where we cover 4-stroke theory